We present heterogeneous robot collaboration in unstructured environments with grounded generative intelligence. Consider a team of robots tasked with triaging an area for damage. An effective planner will first infer necessary subtasks. It will then assign these subtasks to robots based on subtask dependencies and unique robot capabilities. Finally, the planner will adapt to feedback acquired online, generating new subtasks if needed. Because missions often occur in unstructured environments where there are little to no prior maps, the terrain is complex and hazardous, and the planner must operate in a perception control loop, plans must be grounded in robot context in order to be effective. Prior work in this vein either operates in unstructured environments but requires fixed specifications, or uses language specifications but only in controlled settings. We bridge this gap via a method for heterogeneous robot collaboration that, given language specifications, generates grounded subtasks, assigns these subtasks to robots based on capabilities, then adapts and refines its plan based on feedback acquired online, enabling operation in real-world unstructured environments. Our framework takes as input language specifications for the mission and team. It then uses an LLM to generate appropriate subtasks given these specifications. These subtasks are validated for realizability and modeled via a graph to identify dependencies while enabling parallel execution of independent subtasks. These are then assigned to robots, and as these robots execute their subtasks, they gather updates in the form of subtask outcomes and semantic maps, which are aggregated into a common representation, converted to a textual interface, then given back to the first module for subtask refinement. We evaluate our framework in a semi-urban office park and rural and urban simulation environments. We walk through an example experiment where a team of a UAV, Jackal, Spot, and Husky is tasked with locating a chemical barrel. The planner sends the UAV to build an overhead map of unknown regions that are relevant to the mission. Concurrently, the planner tasks the Jackal to act as a communications relay and the Husky to triage rougher terrain. Once the UAV comes back with its map, the planner tasks the Spot, which is the fastest robot in the team, to survey this new but distant region. During exploration, the Spot discovers a barrel, and it then forms a vision language model query to gather precise and mission-relevant information. It then interprets this information and updates the user on its findings, thus completing the mission. We evaluate with a total of 40 experiments in scenarios involving logistics, assistance, and emergency response, all with unique specifications and team configurations. We find that compared to previous LLM-enabled approaches, our framework is over 2 times as successful, while 3 times more efficient in terms of subtasks and tokens required. In real-world experiments, our framework achieves an 87% success rate in complex missions. In summary, we present a framework for heterogeneous robot collaboration with language specifications. It grounds the generative intelligence of LLMs in robot context via online feedback and validation, enabling the first deployment of LLM-enabled teaming with up to 4 distinct platforms in real-world unstructured environments. Thanks for listening.